November 2019. The estuary of the Mile River, Australia. 7,500 tons of rock plunge onto a lifeless oceanic floor. But if the objective is cultivating an oyster reef, why deploy stone rather than oysters? 12 months later, researchers documented a figure that strains credulity. 50 million immature oysters colonized the fresh foundation autonomously during the initial summer season. What transpired next defies expectation even further. These organisms purified the currents, returned crystalline clarity to the depths, and converted barren sediment into a thriving habitat teeming with fish, crustaceans, and sea urchins. Yet the most remarkable detail is this. Culinary establishments across Sydney spent years stockpiling dining refuse so that a vibrant ecosystem could emerge from it. That trajectory proved immensely more complex than it appears. How exactly did this unfold? In 1770, Captain Cook sailed into Botany Bay, drafting the premier official European record regarding what lay beneath the waves: reefs. These formations were massive, impenetrable, and clearly observable right from the vessel's deck. The pioneer settlers who arrived subsequently characterized the oyster networks within Sydney Harbour as perilous maritime obstacles. Their sheer volume forced frigates to steer carefully around them. Within Port Phillip Bay alone, situated in the Southern Territory, these structures blanketed 25% of the entire seabed. Eventually, the settlers required quicklime to construct government facilities, storage depots, and penitentiaries. Lacking accessible limestone quarries, they utilized the reefs resting conveniently in the shallow waters. Shells were harvested, incinerated, and transformed into building materials. For Sydney, assembling itself brick by brick throughout the 1800s, the oyster habitat served merely as a submerged excavation site. Then arrived the era of drag netting. During the 1950s, mechanical dredges scoured Port Phillip Bay, pulverizing whatever remained. Subsequent eras brought heavy siltation from agricultural clearing and river runoff, followed by pathogenic outbreaks and invasive intruders. The consequence, detailed within a peer-reviewed 2018 analysis published in PLOS 1 and heavily referenced thereafter, revealed that 94% of Australian oyster territories had vanished following European settlement. Barely 6% of Cook's original observations endured. To grasp the magnitude of that decline, an American parallel renders the statistic comprehensible. Chesapeake Bay, the most expansive estuary across the United States, possessed an ecological peak where resident oysters filtered the entire aquatic volume of the basin, 19 trillion gallons of water in a single week. Every single drop within 7 days. That capacity guaranteed crystalline visibility, submerged meadows thriving along the floor, and aquatic life occupying every branch of the channel. Presently, the Chesapeake biomass hovers below 2% of its historic baseline, and filtering that identical aquatic mass no longer takes a week. The process now demands a full year, 52 weeks instead of 1. That illustrates the reality of losing 98%. Australia lost 94%. That 4% variance offers no foundation for celebration. It merely indicates that specific degradations within Australia have not progressed quite as completely yet. By the dawn of the decade commencing in 2010, marine experts located merely a handful of isolated clusters featuring the flat oyster, Ostrea angasi, resting along the silty margins of waterways, practically invisible. The formal classification became functionally vanished, indicating the organism persists but lacks the capacity to fulfill any ecological duty. Barren sediment occupied the exact coordinates where vibrant structures once flourished. Here, Charlotte Jenkins joins the narrative, a biological specialist operating within the New South Wales Department of Primary Industries Fisheries, transitioning from preliminary environmental audits to financial justifications, ultimately co-authoring the economic evaluation that decided the fiscal destiny of the entire initiative. The concept she and her associates at the Nature Conservancy Australia championed sounded provocatively straightforward. Supply oysters with a rigid foundation, and they will return autonomously. Simply provide them an anchor point. The critics voiced immediate opposition, presenting valid technical arguments. Point 1. For an oyster to colonize a fresh foundation, it must initially arrive as a drifting larva carried by local currents. Achieving that requires mature oysters capable of spawning to exist somewhere in the immediate vicinity. If the population has faced virtual eradication across hundreds of kilometers of shoreline, identifying the source of that biological seed becomes impossible. A flawless foundation lacking drifting larvae represents nothing more than overpriced rocks resting on the ocean floor. Point 2. Mud cannot sustain weight. Even assuming you deposit rigid materials across a soft estuarine floor, those structures will inevitably submerge within a few seasons, particularly within zones experiencing vigorous tidal shifts and continuous silt accumulation. Point 3. This specific undertaking lacked any historical precedent. Nobody had attempted this within Australia, never with this exact species, never inside tidal estuaries, and certainly never at this massive scale. While the Nature Conservancy possessed background knowledge from comparable initiatives operating within Chesapeake Bay and the Gulf of Mexico, Sacostria glomerata, known as the Sydney rock oyster, represents a distinct biological entity exhibiting completely different larval tendencies. The critics possessed accurate insights regarding those specific details. They merely failed to perceive the broader canvas. In 2015, the initial trial functioned purely as an experimental endeavor. The crew evaluated one specific metric, wondering whether anything could endure atop a lifeless floor. Merely tossing oysters into the tide proved unsuccessful. Larvae lacked the ability to bond with silt. They required rigid architecture. That realization provoked another inquiry regarding what materials should constitute that architecture. The solution emerged from an improbable sector, the culinary industry. The operational mechanism they engineered functioned like this. The Nature Conservancy Australia initiated a campaign titled Shuck Don't Chuck. Dining establishments, aquatic food markets, and event catering enterprises commenced stockpiling utilized shells from oysters, mussels, and scallops, surrendering them instead of dispatching them toward municipal landfills. These remnants traveled toward a quarantine compound where they rested for a minimum of 6 months to neutralize any potential pathogens. Subsequently, they transferred into a cultivation facility where laboratory-raised oyster larvae attached to them under heavily monitored conditions. Finally, those seeded fragments traveled toward the rehabilitation coordinates. Simultaneously, investigators resolved the foundation dilemma. Limestone, gravel, and heavy stone blocks represented the only materials capable of resisting the downward pressure characteristic of a soft estuarine bed. By 2019, once financial backing finally materialized from state authorities and the federal reef builder Endeavour, a heavy transport vessel ferried 3,300 tons of stone alongside 180 cubic meters of repurposed shell straight into the estuaries of the Mile and Karua rivers. That specific shell volume originated from regional oyster cultivators operating around Port Stephens. The culinary recycling campaign operated concurrently across other territories, specifically regions where agricultural operations had virtually vanished, leaving urban hospitality venues as the solitary source for shell material. Yet the critics presented one final inquiry. Between Sydney rock oyster shells or solid stone, which material captures drifting spat more effectively? Jenkins and her unit resolved that debate directly within the aquatic environment. They established parallel testing grids, featuring exclusive stone layouts alongside combinations of stone mixed with shell, and meticulously tallied the results. 2 years later, BMC Ecology and Evolution published those definitive findings. Spat concentration across bare stone within the Mile River reached 1,790 individuals per square meter. Across the shell combinations, the density registered significantly lower. Stone undeniably proved to be the superior anchor point. However, a massive question continues hovering over this entire endeavor. If the skeptics correctly assess the situation, where did those 50 million larvae originate? Assuming the population had practically vanished, an explanation exists, clarifying exactly why the consortium selected Port Stephens specifically, bypassing every other barren stretch of coastline. Within the Mile and Karua basins, fragmented historical reefs had endured. These resilient clusters continued reproducing, releasing larvae into the currents annually. They simply lacked appropriate surfaces for attachment. Silt cannot support weight, meaning those organisms simply faded away. The Department of Primary Industries pinpointed this specific location using that exact parameter. They deposited the stone exactly where the aquatic environment already contains suspended offspring. Port Stephens demonstrated a naturally elevated baseline of larval attachment. That prerequisite underwent rigorous verification during a preliminary evaluation back in January 2019, a complete 12 months prior to the massive structural deployment. The researchers positioned analytical grids measuring 0.5 meter by 0.5 meter, carefully enumerating the volume of organisms that anchored themselves over a single season. The resulting concentration thoroughly justified deploying 3,300 tons of heavy material. Consequently, the ultimate response to those critics did not claim they were incorrect. It acknowledged their absolute accuracy, confirming that their logic dictated the selection of this precise geography rather than an arbitrary zone. That realization delivered a surprising twist for an organization that had dedicated immense energy toward the culinary shell retrieval program. Repurposed shells remained integrated into the blueprint, but transitioned into a supplementary role rather than the primary architectural element. Following the inaugural summer after the Foundation's deployment in 2020, researchers tabulated the biological expansion. 50 million oyster larvae anchored themselves across the fresh architecture naturally, without requiring any artificial laboratory seeding. Following 2 years of continuous observation, these structures processed surrounding currents at a velocity of 7.5 million liters per hour. That equals the volume of 3 Olympic swimming pools every 60 minutes, achieved by a colony less than 3 years old. While natural equivalents covering identical dimensions process slightly higher volumes, the disparity no longer represents a catastrophic gap. Finfish populations surrounding the rehabilitated perimeter expanded by 10%. The variety of aquatic species broadened by 15%. Following these ecological victories, the fiscal evaluation emerged in 2024. The endeavor required an investment of $3 million. The calculated net present value delivered to the community reached $40 million. The return ratio approached 14-to-1. Projected forward, the subsequent expansion tier promises an economic value of $81 million, pushing the return ratio past 15-to-1. However, what materialized alongside these structures astonished the entire consortium. The specialists anticipated improved filtration. They modeled enhanced aquatic clarity. They calculated the probability of biological endurance. What they completely failed to predict was the arrival of anglers. Dusky flathead and yellowfin bream, both highly prized recreational catches within Port Stephens, started schooling around the fresh architecture. Marine biologists secured acoustic transmitters onto 20 specimens from each category, monitoring their navigational patterns across 120 days. Throughout that duration, they logged exceeding 100,000 individual coordinates. The data revealed that dusky flathead advance into the shallow structures during high tide, utilizing the stone and shell for concealment, before withdrawing as the water recedes. The habitat transformed into both a sanctuary and a foraging ground. Anglers realized this reality long before the academic observers did. Individuals who had cast lines across the Mile estuary for years, intimately knowing exactly which zones held nothing, suddenly recognized where the action had shifted. This dynamic introduced an entirely unanticipated complication. Anglers began harvesting catches directly above the rehabilitation sectors. Those acoustic tracking devices highlighted the precise coordinates where flathead and bream congregated. The recreational fleet observed those identical aquatic patterns, arriving equipped with tackle and nets. From an environmental perspective, this represents a massive victory. The habitat functions perfectly. The marine life returned. Citizens observed tangible success firsthand. From an administrative viewpoint, it introduces a fresh variable completely absent from the initial projections. If harvesting intensity accelerates faster than the biological foundation can mature, the entire recovery trajectory might decelerate simply because fishing vessels clustered around it. The regulatory authorities documented this phenomenon. No definitive solution exists yet, only ongoing observation. Yet this exact situation illuminates a profound truth. The instant an ecosystem initiates recovery, it instantly magnetizes human attention. That attention perpetually functions as both a vital asset and a heavy burden simultaneously. The structure draws marine life. The marine life draws the fleet. The fleet focuses public awareness upon the initiative, providing the singular justification compelling the regional council to endorse the subsequent financial phase. Simultaneously, they generate an extraction pressure requiring careful governance. It forms an unbreakable loop. Oysters cultivated within Port Stephens constitute a major commercial enterprise. Between 2019 and 2020, commercial harvesting operations across the district generated $10 million annually. By the period spanning 2022 through 2023, those revenues plummeted to $6,900,000. The triggering factors varied, including pathogenic outbreaks, severe atmospheric disturbances, and mechanical dredging operations. However, the overarching theme remains systemic instability. From the governmental perspective, this rehabilitated ecosystem functions as foundational infrastructure supporting everything else. It maintains the aquatic purity necessary for agricultural oysters to thrive, sustains the finfish populations targeted by recreational enthusiasts, and nurtures the submerged landscapes drawing diving tourism. Persuading the agricultural and recreational sectors of these benefits initially proved incredibly difficult. Without their active endorsement, the initiative could secure neither regulatory approval nor operational expansion. Charlotte Jenkins and her associates dedicated years of effort long before depositing a single stone, mediating discussions alongside angling associations, regional governance boards, the Warramai Local Aboriginal Land Council, and aquaculture delegates. The architecture resting at the Mile River mouth consists of more than mere stone. It was constructed entirely from complex diplomatic agreements. That reality represents the true core of this endeavor. One specific occurrence highlights this reality better than any numerical metric. Upon completing the structural deployment, the Warramai community executed a traditional cleansing ritual upon the water, potentially marking the first historical instance of this ceremony occurring directly atop the estuarine surface, rather than along the shoreline. The dual habitats earned formal designations drawn from the Warramai vocabulary: Bindayima Guba Ninang and Garua Guba Ninang, translating to Black Possum Oyster Home and Oysters of Sea Country. The structure now resides within a biological network and simultaneously occupies a place within human language. This matters deeply because the paramount obstacle confronting aquatic restoration globally rarely involves biology. It involves human management. If local populations distrust an initiative or acknowledge its validity while perceiving zero personal advantage, the endeavor cannot expand. It merely remains an elegant academic exercise, generating published manuscripts until the financial backing evaporates. Within Port Stephens, at least temporarily, that dilemma stands resolved. But temporarily remains a crucial distinction. Currently, the Reef Builder Initiative, representing the federal Australian program financing the Port Stephens operation, encompasses 13 distinct coordinates, spanning the continent from Botany Bay toward Oyster Harbour across Western Australia. The overarching objective targets rehabilitating 30% of the historical oyster territories. 30% of that residual 6%, surviving the massive 94% collapse, represents the absolute minimum baseline required for a biological network to sustain itself autonomously. We conclude with a mystery lacking a definitive resolution. Inside Waganga Inlet near Narooma, an entirely different methodology recently commenced: a living shoreline project. This represents the premier attempt across New South Wales to re-establish a submerged colony of the flat oyster, Ostrea angasi, that exact organism classified as functionally vanished throughout the majority of its ancestral territory. The specialists utilized an artificial remote colonization technique. They cultivated 2 million immature organisms upon processed shell fragments inside a laboratory environment before transporting them into the wild. Attrition from natural marine consumers proved immensely high. During the subsequent cycle, they altered the methodology. The juvenile organisms remained inside the laboratory environment significantly longer before moving into protective submerged enclosures. 600,000 fresh individuals entered the water. Their ultimate endurance rate remains an unknown variable. Nobody can definitively state whether an organism absent from a specific coordinate for centuries will successfully re-establish dominance. Does a natural environment remember exactly what it lost? Assuming the local marine consumers devour this second deployment, the specialists remain uncertain whether a third alternative even exists. A simultaneous dilemma shadowing every similar endeavor involves identifying the financial patron once the initial grant money inevitably runs out. The Port Stevens operation required $3 million. The forthcoming expansion demands substantially more capital, and the blueprint includes 13 separate locations. The habitats are expanding. They continuously process the currents. They actively summon marine life. Yet they possess no ability to convince the incoming political administration to authorize the necessary funding. If you appreciate deep investigations into the hidden mechanics of our natural worlds, consider subscribing to the channel.